A North Jersey homeowner's guide to radioactivity in drinking water when it comes to uranium. This is something that is very serious. Naturally occurring radioactive substances are frequently found in groundwater in New Jersey, and they are present to at least some extent in almost all rocks and soils. So when people think, well, maybe uranium's kind of rare, it's just not the case. Radioactivity in drinking water is also not a new phenomenon, having been present to some extent since the Earth was formed. And despite that history, uranium in drinking water above the standard may be harmful to your health. Radionuclide testing of public drinking water systems has been required since the 1970s. However, uranium testing has not been required until recently. So just because the testing was there doesn't mean people were picking it up. Just like in heavy metals, maybe they test for lead, but they don't test for other things like copper, iron, things like that. That still needs to be tested. So this is actually recently. You might have thought, oh yeah, they've been testing uranium for a while. It might not be the case. Concentrations of uranium in drinking water above the U.S. EPA's maximum containment level over a long period of time is believed to cause kidney damage and to increase one's lifetime risk of developing certain type of cancer. Therefore, this homeowner's guide was developed to provide important information for homeowners who are interested in testing their private drinking water wells for radioactivity and reducing their exposure. Geologically, high levels of uranium in drinking water are most likely to be found in Highlands Province and the neighboring regions of New Jersey. It is also possible for radium and radon in water to be found in this area. The Highlands Province lies within the southeast portions of Sussex and the Warren counties, as well as major portions of the Hunterdon, Morris, and Passaic, and small parts of Bergen and Somerset. In Pennsylvania, this region is called the Reading Prong, while in New York, it's called the Hudson Highlands. And we also have radioactivity. How is it measured? Well, radioactive substances are those unstable in nature, naturally occurring in uranium, thorium, and radium and radon, and they emit radiation to reach a more stable condition. And this process is called radioactive decay, and by measuring the type of radiation emitted, the specific energy level or levels of radiation and rate of decay, scientists are able to identify a radioactive substance and determine how much of it is present. Radioactivity is usually measured in curies in the United States, and the unit typically used to describe the concentration of radioactivity present in drinking water is per curie per liter, or 1/3 of a curie. Uranium is also expressed in micrograms per liter, a mass per unit volume measurement, and a microgram is 1/1,000,000th of a gram. So what are the risks? About 99% of uranium ingested food or water will leave a person's body in the feces, and the remainder will enter the blood. And that's where the problem happens. Most of the uranium will be removed by the kidneys and excreted in the urine within a few days. That being said, what is the procedure for testing? Due to the highlands geology, the likely source of radioactivity in drinking water is uranium, radon, or both. And a gross alpha test is the first step to determining the type and level of radioactivity in the drinking water, and this test serves as a preliminary screening and determines whether additional testing is advisable. And a gross alpha test typically costs $75 from $150, and the gross alpha standard in New Jersey is calculated by first measuring gross alpha activity and then subtracting the uranium and radon contributions from this value. If the gross alpha test result is above 50 per curies per liter, then further testing for uranium, radium, and radon is recommended, since all those radionuclides are found in part of the state. With uranium and radon being the most prevalent, the additional tests are necessary in order to ensure correct treatment is installed, and each requires a different kind of treatment. Standard for uranium is 30 micrograms per liter, and the cost of testing uranium is approximately $200. And there is no current standard for radon in drinking water in the EPA, and they propose a level of 4,000 PCI as an alternative MCL, assuming the community water system contributes to mitigating radon in air and water problems throughout the state. So as we can see, this is a huge issue with uranium, radon, and it's quite prevalent and ubiquitous in drinking water. It's not something that's rare or something you see just around nuclear power plants. This is a pretty big issue. That's why it's always a good idea to periodically test your water for uranium and other contents like it.